Welcome to this presentation about the PCA9685 and LED problem solved. We won't waste any time, so let's start. But first, just a quick view over the PCA9685 specifications and functionality. It is a 12-bit 16-channel PWM pulse wide modulation controller. It can operate in the range from 2.3 to 5.5 volt. It is using the I2C bus to connect to the microcontroller. Up to 62 modules can be connected daisy-chained after each other on one I2C bus, giving a total of 992 channels per bus. The PWM signal is a 12-bit, gives 4096 steps in 24 to 1526 Hz. Typical use to controlling servers and LED. It also have an external input power, V+, to power servers and LEDs. Nice! So what is the LED problem then? There is no problem connecting servers. There is no problem connecting a few LEDs. But if you want to connect many LEDs, that need to be handled in a certain way. Most videos describing the PCA9685 don't address this issue. Let us look at the PCA9685 connectors. SCL clock and SDA data is the only two connectors needed for the I2C bus, here marked green and orange. Then we have ground and VCC that power the PCA9685 internally, here marked black and red. We also have a V+ input for an external power of X volt and amp. The V+ power could be either connected to the green screw terminal that is polarized protected or to the V+ pin that is not protected. The V+ power output is on all the 16 red pins. Then we connect the signal to the microcontroller. Here we're using an ESP32. The 3.3 voltage output connecting to the VCC should not having more load than about 150 to 200 milliamp. ESP32 also have a 5 volt output. Do not connect to that output, because the I2C bus pull-up resistors on the PCA9685 would be using 5 volt back to the ESP32, and that would be no good. The 3.3 volt VCC is what coming out on the 16 yellow PWM pins. Normally, we would connect the LED by having the LED's anode plus to the yellow PWM pin, and the cathode minus to the common black ground pin. That, however, would limit the number of LEDs that we could connect because of the 150 to 200 milliamp limit on the PWM pins. Depending on how many LEDs that would be running at the same time and on what power, you typically could connect about 5 to 10 LEDs. That is what I call the LED problem. But when there is a problem, there is also a solution or solutions. You could have a component like a shift register, but this solution doesn't require any hardware. Connect an external power to either the screw terminal or to the V+ pin. For LEDs, a 5 volt external power should be a good choice. Then connect the LED's anode plus to the red V+ output pin. Connect the LED's cathode minus to the yellow PWM pin. Make sure that the ground from the microcontroller is having a connection to the external power ground. Now you can attach as many LEDs as possible for the external power to handle, but only connect one LED per channel, This is the only cable changes you need to make. We also need to adjust the C++ code to make this to work. First, we include the wire library needed for the I2C bus. And then the PWM server driver. I'm using the Additionell driver. There is others, but I'm used to this one. Then we're initiating the driver at the default address with the name PWM. Frequencies is set per board. All 16 channels will have the same frequency. We set it here to 1500 Hz for a smooth LED dimming, almost the maximum frequency that the board can handle. Standard hobby servers is using 50 to 60 Hz, so mixing LEDs and servers on the same board is not possible because the LED would flicker at this low frequency. By setting the output mode to false, we are setting the driver to something called open drain mode to sync the ground instead of the standard pull push mode. The channels is numbered from 0 to 15 and we are using 15, the last one. The value 2048 is where we start the fading up to 4096 when the LEDs is at the brightest. The value true invert the logic to sinking current. That is all that is needed in the code. Only 2 changes compared to the standard settings. So let's see how this works in practice.
Okay, then we have opened the Arduino IDE, and you can see we have loaded the sketch. It's the same code as you saw in the PowerPoint. So let's compile and upload it to the microcontroller. So we are uploading it, you can see here. And now we have it running. Here we have the breadboard, the 5-volt input, the PCA9685 that connected to the I2C bus to the microcontroller ESP32. And here we have the LED flickering. So the code and the connection is working. If I turn the power off, the LED should stop because now there is no external power.
That's all for this simple but hopefully useful PCA9685 information. But if you're interested, there are and there will be more videos, divided in 3 series. This video is the second E2 in the electronic series. My journey, selecting a hobby and being a newbie, making mistakes and searching for solutions you can follow in a newbie journey series. The last series for now is about the WICS project, Wireless Control System for Accessories. It's an add-on to the no-rail system. If you subscribe, you will have a notification when the videos are released. Also, you will supporting the channel. Thank you for watching this video. Hope you enjoyed it. We are looking forward to sharing the next video with you. Until next time, bye.